All right, let's dive right into this explainer. We're tackling arguably the most urgent and yet totally ignored security vulnerability in agentic AI today. Look, engineering teams everywhere are racing to ship AI agents and RAG pipelines. But in that massive rush, there's a glaring blind spot. We're going to walk through the undeniable proof that your brand new AI agents are almost certainly bypassing your carefully built access controls and basically leaking your company's most sensitive data.
Think about this for a second. You've probably invested a fortune and countless hours in enterprise SSO, identity and access management, and strict role-based access controls for every system in your org. So why on earth are your shiny new AI agents slipping right past all of it? Well, the harsh reality is that when you deployed that RAG pipeline, you accidentally created a massive, brand new access surface that entirely sidesteps those legacy controls. We call this the RAG Authorization Gap. And it's exactly how you get that nightmare scenario where an AI co-pilot, asked a seemingly innocent question about company compensation, suddenly spits out highly confidential executive salaries straight to a junior employee. Yikes.
So here's how we're breaking this down today. We'll start with the agent access gap, move into the 3 specific ways data actually leaks, tear down the illusion of prompt-based security, introduce the principal model as a fix, and finally, look at why an immutable audit trail is an absolute must.
Let's jump straight into our first piece of the puzzle, the agent access gap.
Here is the fundamental paradigm shift. You see, traditional security was built for humans, and humans are slow. We browse UIs, we click around, and access decisions are made with explicit checks for every single file before we ever see it. But agents? Oh, they are a totally different beast. They operate hidden in the background, firing off rapid API calls to vector databases. And crucially, they execute what we call semantically greedy retrievals, meaning they blindly grab dozens of records all at once just based on meaning, completely oblivious to who is actually asking, or what that specific user is explicitly permitted to see.
Now that we see this massive gap, let's look at exactly how the data gets out. Section 2, the 3 ways data leaks.
What's wild is that these 3 leakage vectors happen entirely behind the scenes. First up is over-retrieval. A vector database is designed to find meaning. It's not a security guard. It's going to return relevant chunks no matter who is asking. Then you've got cross-tenant bleed. Because semantic retrieval basically lacks strict query time boundaries, things get messy fast. And third, stale permissions. Say a document's classification suddenly flips to restricted. Well, that policy change almost never trickles down to update the thousands of embedded vectors already sitting in your database. So your LLM ends up synthesizing all these chunks, quietly blending highly restricted data with public knowledge before the user even gets their answer.
So how do we fix this? Well, a lot of people think they have a shortcut. Let's move to Section 3, the prompt illusion. You might be thinking, hey, I'll just use a clever system prompt. I'll just tell the model to only show what the user can see. But relying on prompt instructions is a really dangerous illusion at agentic scale. Prompts just aren't enforceable policies. They are trivially bypassed by prompt injections. Okay, what about vector database metadata filters? Unfortunately, they are static, brittle, and not retroactive. And embedding permissions directly into the vectors? Honestly, that's an absolute nightmare. Every single policy change would force an incredibly expensive re-embedding of your entire data corpus. And your existing IAM? Well, that governs system-to-system access. It does absolutely nothing to filter semantic retrieval down at the chunk level. The core takeaway here is that permissions are dynamic policy decisions. They are not static tags.
Clearly, we need a better way. Let's look at Section 4, the principal model.
The real fix requires a completely new mechanism that works dynamically at runtime. And this brings us to a purpose-built solution called Gateco and its principal model. Gateco tackles this by acting as a permission-aware retrieval layer. Think of it as this incredibly smart security middleware sitting directly between your AI agents and your organizational knowledge base. It intercepts every single retrieval request. So instead of relying on your VectorDB to magically enforce security, Gateco evaluates that request against your active organizational policies and the user's or principal's identity, right at the exact millisecond of the query.
Through this system, Gateco absolutely ensures that your AI systems only know what they are explicitly allowed to know. And the best part, it integrates with over a dozen different vector databases so you aren't ripping out your existing infrastructure. Instead, every single agent gets its own verified identity and policy, enforcing a really strict deny-by-default environment. No active policy explicitly allowing a retrieval? Then that data is blocked, period.
Let's break down how elegant this 3-step flow actually is. Step 1. Permission-blind recall. The system grabs the top candidate chunks from the VectorDB based purely on semantics. This is just like your standard RAG setup.
But step 2 is where the magic happens: policy evaluation. Here, Gateco synchronously evaluates every single chump against the requesting principal's identity, their roles, and those exact data classification labels. And finally, step 3, secure resolution. The system decrypts and returns only the allowed subset of chunks back to the calling agent. That denied content, it's never exposed to the agent, not even as a reference. What you end up with is pure late binding authorization. Because these policies are evaluated right at query time, if you change a permission today, it applies to the very next query instantly. So picture this: you have two users asking the exact same question against the exact same vector database. With this setup, they will receive completely different authorized contexts and therefore completely different answers based entirely on their verified identity. It's brilliant. Now, what does this look like at enterprise scale? Let's hit our final section, the immutable audit trail.
I want you to consider a single AI agent running, say, 10,000 background retrievals in a single day. Without a middleware layer in place, you literally have zero visibility into what data that agent just pulled and synthesized. It's a complete black box.
But when an agent operates at that massive scale with Gateco, it maintains an immutable, compliance-ready audit trail for every single one of those retrievals. We're talking exact logs of who asked, down to the principal ID and identity source. It logs the connector used, it tracks the exact number of chunks allowed versus denied, and the specific policy IDs that made that decision. For any engineering or compliance team, this is the exact concrete evidence that upcoming regulations like the EU AI Act or SOC 2 audits are going to demand. You can definitively prove exactly why a piece of data was withheld.
And I know you're probably thinking, this is going to kill my latency, right? Actually, no. Incredibly, this intense policy enforcement adds less than 25 milliseconds of latency overhead per query. Your agents stay blazingly fast. On top of that, the whole architecture is completely fail-closed by default. If there's ever a glitch in policy evaluation, the retrieval is just denied. There is absolutely no silent data pass-through.
To wrap up this explainer, I really want to leave you with this definitive architectural takeaway. Authorization must happen after semantic recall, but before answer generation. This boundary is quite literally the only place where access control is both meaningful and enforceable in an AI system. So I'll leave you with this question. If you aren't enforcing strict identity-based authorization right at this exact boundary, what else is your AI agent quietly leaking right now?